Hello, my remarkable pre-calculus class. We are ready for another online adventure. Today, we will find all possible exact solutions for trigonometric equations involving sine and cosine. Well, exactly what is a trigonometric equation? Trigonometric equations are equations that involve trigonometric functions. The values that satisfy such equations are called solutions. Trigonometric functions are periodic. That means that they repeat like every 2 pi units. Therefore, we're going to have infinitely many solutions. We're going to solve this equation. We're going to find all possible exact solutions for the equation cosine of theta is equal to 1/2. Well, we're going to solve for theta using our inverse trig functions. Theta is equal to inverse cosine of 1/2. And remember, we use inverse trig functions when we're looking for an angle. Cosine is positive in the first quadrant and the fourth quadrant. Remember, a smart trig class? Here I've just written down what I just said. Cosine is positive in the first and the fourth quadrants. So we're going to look on a unit circle. We're going to look at quadrant 1. Quadrant 1, the cosine, remember, it's the x-coordinate. And the x-coordinate here, that's a positive 1/2, is pi over 3. Then in the fourth quadrant, looking for a cosine where the cosine is a positive 1/2, it's right here, 5 pi over 3. So in quadrant 1, we have theta being pi over 3. In quadrant 4, we have theta being 5 pi over 3. So that's what I've written down here after looking on what the unit circle. Theta equals pi over 3 in quadrant 1. And theta equals 5 pi over 3 in quadrant 4. Because, because the period of the cosine function is 2 pi, any multiple of 2 pi can be added to these values. So we're going to look at all the solutions for solving this equation. And they're given by pi over 3 plus 2 times k times pi. You see, we're adding multiples of 2 pi. Theta is equal to 5 pi over 3 plus multiples of 2 pi. Now, the k is an integer. Remember, integers, no fractions, no decimals, all positive and negative whole numbers and 0. So here, we've written out all the exact solutions to the solving of the equation cosine of theta is equal to 1/2. Sometimes authors don't put the plus or minus sign there. They will just put theta equals, and I'll just put this, this being our solution. Theta equals pi over 3 plus 2k pi, and theta equals 5 pi over 3 plus 2k pi. And they don't put the plus or minus because you see k is an integer. You give you a plus or minus 1 or plus or minus 2, plus or minus 3 like that. So that's why sometimes some authors don't put the plus or minus. Excuse me. Okay, let's do another example here. Find all possible exact solutions for this equation. Well, you see we have our trig function because it has a trig equation rather, because we have a trig function in it, sine of x. We want to get sine of x all by itself on one side. So we're going to subtract 5 sine of x from both sides. 3 sine of x minus 5 sine of x gives us negative 2 sine of x. Then I bring down the minus 2. This 5 sine of x minus sine 5 of x just adds up to give us 0. Then I bring down the minus 1. Then I'm going to add 2 to both sides. Negative 2 plus 2 is 0. So I just bring down the negative 2 sine of x. Negative 1 plus 2 is a 1. Then I would like to divide each side by 2 to get the trig function all by itself. Sine of x is equal to a negative 1/2. So when we do that, remember that we're looking for an angle whose sine is a half. So I can say something like this: x is equal to inverse sine. X is equal to inverse sine of a negative 1/2. That way you see I'm solving for x, because I'm looking for x. What is the angle? And also remember that the sine, the period for the sine of x is also what, 2 pi radians? And because the period is 2 pi, any multiple of 2 pi can be added to these values. So you're going to have an infinite set. Now, it was an inverse sine is equal to negative a half. Well, a smart trig class, sine is negative in the third and the fourth quadrants. So I'll make a note that sine is negative in the third and the fourth quadrants. When looking at our unit circle, we're looking for a negative a half. So let's go to the third quadrant right here. The sine is the y coordinate. See, sine is the y coordinate. And that angle is 5 pi over 6. Then we're going to look at the fourth quadrant. We're looking for a sine that is a negative a half. And that's the y coordinate. And you see right here, that's 11 pi over 6. 11 pi over 6. So that's why I said if you look on the unit circle, x equals 7 pi over 6 in the third quadrant, and x equals 11 pi over 6 in the fourth quadrant. But we would like to get all exact solutions. So what we're going to do, we're going to add to each one of these angles, we're going to add 2k pi, which is a multiple of 2 pi. And we add that plus or minus 2k pi to the 7 pi over 6 and the 11 pi over 6. And remember now, k is an integer, no fractions, no decimals. So what we have here will be all the exact solutions that we have found. And remember, as you are reviewing this video, to stop, rewind, review. Stop, rewind, review until you understand what has been gone over. And my love goes out to you